Imagine an AI running 85 unique quality assurance checks on a web app. Beat. Then, downloading monthly bank statements from a secure portal that has absolutely no API.
Right, just visually navigating it.
Exactly. And finally, turning a raw YouTube video into a perfectly formatted X article draft with screenshots placed exactly where they belong. All of this happening from one single setup.
It really completely shifts our mental model of how we interact with software. It's a genuine leap forward.
Welcome to the deep dive. Today, we're figuring out how this is actually happening. We're looking at AI browser agents, specifically the Codex desktop setup.
Yeah, the one that's been making waves recently.
Right. And we're exploring how they finally learned to see and click the web exactly the way you and I do. For years, the boundary of automation just stopped at the API.
If an app didn't have a backdoor for code to talk to code, you were kind of out of luck.
You really were. But now, that boundary is entirely gone.
Yeah, and it's a fundamental shift in capability. I mean, we're moving from systems that read underlying code to systems that visually reason with rendered pixels.
We have a really clear roadmap for this deep dive. We're going to unpack 3 very different real-world workflows to understand the mechanics here.
Got to keep it practical.
Always. We'll start with automated QA testing, move into the strict security of banking, and then tackle the inherently messy world of content publishing.
And then we'll break down a core decision framework so you know exactly when to unleash an agent versus relying on a standard script.
Because it's all about practical application. We want to keep your AI automation pipelines actually useful instead of, letting them turn into a chaotic mess.
Exactly. Nobody wants an AI just wildly clicking around their computer.
No, definitely not. So let's start with the mechanics of the setup itself. We're talking about the Codex desktop application.
Right.
When you open it, you get this split screen. You have your chat interface on one side and an in-app browser on the other.
And that side-by-side view is critical for building trust. Both you and the agent are looking at the exact same rendered page at the exact same time.
Right. You type your plain English instruction on the left and just watch Codex physically control the browser on the right.
Yeah, you're actually watching every single click, scroll, and form fill happen in real time. It's wild to see.
It really is. But before we get into unleashing this thing on actual workflows, we need to establish a mental model for automation.
Yes, because having a powerful tool is useless if you deploy it wrong. The golden rule here is incredibly simple. API first, browser use second.
Let's unpack that a bit. An API is a direct code connection for apps to talk. It's like a secret backstage door.
Perfect analogy, yeah.
It's incredibly fast and it's perfectly stable. But browser use, that's like standing in line at the front door using human eyes to navigate the lobby.
That's exactly it. I mean, most established tools already have APIs. Codex actually has hundreds of built-in plugins for them. So you always try the API first.
Because it's cheaper and faster.
Right. Browser use is your fallback power move. You deploy it when a platform has no API or when the API is heavily restricted.
Or when an API makes simple user interface work incredibly painful, which happens a lot with formatting text or images.
Oh, constant.
So there are 2 modes of operation we need to clearly define here.
Headed mode and headless mode.
Right.
Headed mode means you watch Codex work visually in real time. This is your training phase.
And headless mode means running silently in the background without a visual interface.
Exactly. That's the handoff phase where the computer just does the work silently.
I have to admit, I still wrestle with prompt drift myself when giving these vision agents instructions.
Oh, we all do.
You think you're being crystal clear. You say, summarize this page. But the AI interprets it entirely differently and starts clicking into menus you never intended or writing a 10-page essay.
Yeah, which is why you really need that visual confirmation at first, to ensure it grasps the context.
You absolutely do. You watch every move in headed mode. You fix the instructions when it inevitably misunderstands a layout.
You're essentially making sure the agent truly understands the visual hierarchy of the page.
Yeah.
Only when the workflow is perfectly stable do you tell it to run headless.
And what's brilliant is that Codex even shows its own little ghost cursor when it takes control of the screen.
That's a highly reassuring touch. You always know exactly who is driving the machine.
Yeah, beat. So how do you ensure the agent actually understands the page before you trust it to do real work?
Well, you basically observe its cursor movements during those initial headed runs to verify its visual logic and decision-making.
So headed mode first to watch it learn, then let it fly headless.
Precisely. It builds the necessary trust before you step away.
Okay, if we understand how the agent sees a page, let's look at what happens when we unleash it.
Let's do it.
We want to see how it finds both visual and functional flaws in a piece of software.
This brings us to our first major workflow, automated QA testing. Essentially letting Codex try to completely break your app.
Right. Think about a typical development environment. You spin up a form submission app on your local network.
On your local host, yeah.
In this scenario, Codex ran 85 highly focused QA checks, mimicking a real user flow.
Now, a standard automation tool looks at the DOM, which is the underlying code structure of a web page. But Codex uses vision.
Which is completely different.
Entirely. At first, this test page had some very obvious UI problems. Like the spacing looked entirely wrong. A phone number field was visually out of bounds, physically covering the company text field.
These are exactly those annoying layout bugs you spot by eye. The ones you usually try to explain terribly in a Slack message to a frustrated developer.
Yeah, the box is weirdly over the other box. But Codex has a specific feature called Annotate to solve this.
How does that work?
You open the app in the in-app browser. You click the Annotate button. You visually click the broken element on the screen.
Like pointing a finger.
Exactly. Then you just describe the issue in plain language. You type, this phone number box is out of bounds and covered in the company box. Fix the spacing.
And you can add multiple annotations across the screen, right? One for bad spacing, one for poor alignment, one for a broken input field.
Right. And then you send all of those notes into the chat. Codex processes the visual context, dives into your files, and turns those visual notes directly into coding tasks.
It literally writes the fix.
It does.
But that's just the superficial visual pass. The real test starts when you ask it to behave like a user.
Oh, yeah. You give it a beautifully chaotic prompt. You say, use your browser and test the heck out of this app. Try your best to break it. Report every bug you find and what needs fixing.
Let me push back slightly on this, though, because we already have entire teams dedicated to human QA testing.
True.
And humans inherently know what a functional app is supposed to feel like. Isn't AI simulating chaos actually better than a trained human eye?
It often is, primarily because of fatigue.
Yeah.
I mean, human QA is incredibly important, but humans usually test the happy path.
Right, the way it's supposed to work.
Exactly. We maybe check 5 or 6 edge cases before we get tired or bored. Real users do incredibly strange things. They skip fields, they navigate backward, they hit submit way too early.
They mash the keyboard instead of clicking buttons.
All of that. And an AI told to break the app doesn't get tired. It simulates that human chaos perfectly and relentlessly.
The results from this specific chaos testing are actually fascinating.
Yeah. It found that invalid contact data successfully passed validation. So bad user data could corrupt the backend system.
Wow.
It also found that the UK country code silently reset back to the US after a user edited their profile.
It also dynamically found mobile responsiveness issues, which is wild.
Yeah, it resized the browser and switched to mobile view entirely on its own. Nobody specifically asked it to check that layout.
The app looked completely fine on a desktop monitor, but the navigation broke entirely on phones. And the vision model recognized the overlap.
It's just seeing the screen. And there's a scaling prompt mentioned in the setup that feels particularly powerful. It's called the goal prompt.
Right, you literally type /goal into the chat. Goal, don't stop until you have tested 100 unique edge case scenarios.
You tell the agent to try invalid data, empty fields, strange keyboard submission methods, restart behavior.
And the LLM reasons through every permutation. It returns every single bug with precise steps to reproduce it and suggested code fixes.
And you just send the aggregated list back into the chat and tell it to fix the code base.
Beat. What makes this better than a standard automated testing script?
Well, standard scripts break the moment a developer moves a button. Agents adapt visually to page changes dynamically.
Got it. Real users do weird stuff, and agents simulate that human chaos perfectly.
Exactly. It tests the application visually, exactly as a human would.
So breaking a local development app is relatively low stakes, but how does this agent handle high security environments?
That's the real test.
We need to talk about downloading monthly statements from a bank.
This is a massive recurring pain point for operators. We're looking at the Relay Bank dashboard use case. Logging in securely, navigating to accounts, clicking into statements, and downloading specific CSV files.
And all of this happening without an API? There's no custom code integration, it's just a plain English instruction.
Right. The prompt is simply, open Relay, go to the dashboard, accounts, statements. Download the latest statements for these 2 specific accounts as CSV files, then save them securely into this local folder.
A normal macro, which is a script automating a fixed sequence of clicks, needs the buttons in the exact same pixel location every single time.
Exactly. If the bank shows a pop-up ad, the macro clicks the ad and crashes.
Right. But Codex handles the real dynamic interface. It reads the rendered page as it moves through the workflow.
However, banking platforms introduce a very specific intentional hurdle, the login problem. Banks forcefully log you out. It's a strict security measure.
So if Relay opens up the login screen again, Codex needs a safe way to sign back in.
And you absolutely do not want to paste your raw banking password into an AI chat history.
No, never.
Codex solves this with a built-in password manager. You import a secure CSV file. It has clean columns for name, URL, username, and password.
So it pulls the credentials securely and natively. But what about two-factor authentication? The dreaded SMS text code.
Yeah, the 2FA limit is incredibly real, and frankly, it still needs you in the loop. If the bank sends a code to your phone, you must enter it manually while the agent waits.
Wait, you could technically write an automation to read text messages off a Mac and paste them in, couldn't you?
People certainly try that, but you shouldn't. Banking workflows should always favor absolute control over pure convenience. You need strict stop rules in your prompts to prevent catastrophic errors.
Something like only download statements. Do not click transfer. Do not move money. Stop immediately if the page layout looks different.
Stop if a new 2FA prompt appears, or if the account balance is entirely unclear. That is the only safe way to use an AI browser agent in finance. You do not want it hallucinating a wire transfer.
You really need to watch it run 10 times in headed mode before trusting it with sensitive financial data. So why can't we just automate the 2FA text messages via a Mac to save time?
Financial environments demand hard security breaks, really, to prevent catastrophic automated errors from occurring silently in the background.
Right. Financial tasks need guardrails. Safety always beats total convenience.
Completely. You cannot risk automated, unverified funds transfers.
Speaking of seamless workflows and eliminating friction, we want to take a quick second to thank the sponsors of today's deep dive.
Yes, absolutely.
2sec Silence. Our friends providing the workspace infrastructure that makes organizing all this data possible are truly essential. We appreciate their support in helping us navigate the future of work. Beat. Okay, let's get back to these workflows.
We've thoroughly covered extracting data from secure systems. Now we need to look at content creation.
We've seen how strict the agent has to be in rigid, secure environments like a bank. But what happens when you point it at an inherently messy, creative interface?
Right.
We're talking about formatting a draft for social media.
Specifically, the YouTube to X article workflow, turning a long-form video into a highly polished Twitter draft.
Why does browser use Win here over an API? I mean, X definitely has a developer API available.
It does have one. But formatting rich text through the X API is notoriously messy. It strips out paragraph breaks, media uploads can fail silently.
Plus, API usage costs actual money.
Right. Browser use runs right inside your local Codex setup. It formats the text inside the real X editor interface. It clicks and uploads through the actual browser window.
The prompt you use here is very straightforward, but it's powerful. Turn this YouTube video into an X article. Add screenshots where they fit contextually. Do not publish.
That last part is absolutely crucial. You paste the YouTube link. Codex natively opens the video. It visually scans the frames. It captures highly useful screenshots. It generates a compelling thumbnail image.
Then it physically opens X using your saved session state. It navigates to drafts. It clicks compose, pastes the generated title, pastes the full article body, and uploads the thumbnail.
And it carefully moves images into the correct places within the text flow.
A normal AI writing tool just spits out a massive wall of text that you have to copy. An AI browser agent puts that text into the actual publishing interface for you. It handles all the tedious visual steps around it.
And the actual writing is only half the job anyway. The tedious formatting, the image resizing, the copy pasting, that's where your creative productivity actually dies.
That's precisely why the key rule here is so important. Always force the AI to stop before publishing.
Yeah, let the agent handle the boring browser labor. You step in at the very end for human review.
You check the images, you fix anything that sounds weird or robotic, then you hit publish yourself.
This brings up another incredibly powerful concept: session persistence, what are commonly known as cookies.
All right.
In a fresh Codex chat window, X can still open already logged in because the agent remembers your session state.
So you bypass the login wall entirely and you can just ask it to scan your feed.
Yeah. You say, "Open X, scroll my main feed and tell me what is new in the world of AI." Codex literally browses as you. It visually scans the feed. It summarizes useful trending updates.
In one example, it noticed granular updates around Grokbot and Grok 4.6.
Exactly. And that easily becomes a scheduled daily routine. Every morning at 8 a.m., check my X feed for AI updates, summarize the best posts, and suggest 3 new article ideas.
The pipeline gets incredibly powerful. It finds the core idea, turns a reference video into a draft, places the media perfectly, and prepares the post for your final review. Beat. How much human editing is typically needed after the agent formats a draft?
Usually it's just a quick review, really, to ensure the tone and visual alignment are perfectly suited to your brand.
Makes sense. Let the AI do the heavy lifting, you just add taste.
Exactly. Curating taste remains a strictly human element.
We've been entirely inside the web browser so far. But what happens when the workflow needs to step outside the browser and interact with your actual machine's operating system?
This is the critical distinction between browser use and computer use. They work the exact same way at their core. It utilizes vision, AI reasoning, and direct control of the screen coordinates.
The difference is simply where Codex is allowed to work.
Right.
Browser use is sandboxed for websites and web apps, dashboards, portals, forms. Computer use is for your actual local machine, desktop applications, local system files, in-app settings.
You just go to the Plugins menu, search for computer use, and install it. We have the Glido desktop application example to illustrate this.
You ask Codex, open the Glido desktop app, go into settings, and turn on Bluetooth device support.
It opens the local app. It visually scans the UI to find the settings gear. It switches the Bluetooth toggle on. It's interacting with your operating system.
Whoa. Imagine scaling to 100 unique edge case scenarios or having it actually tweak your computer's hidden network settings while you watch. That feels like a massive leap in how we command computers.
It is a massive leap.
Okay.
And because it operates at the OS level, it requires explicit safety signals. When Codex has control of your actual computer, a thick blue border appears around your entire screen.
So you always know exactly when the agent is driving the mouse.
Right. It also halts automatically for admin passwords or sensitive system permissions.
That visual safety signal is deeply reassuring when an AI has access to your files.
We really need to recap the big idea here. The overarching decision framework for any AI agent automation workflow.
Priority 1 is always the API or a direct plugin. It's structured data. It's the fastest, cheapest, and most stable path imaginable.
Priority 2 is a macro script. This is best when every click is always the exact same. Same screen size, same buttons, same chronological order.
Priority 3 is browser or computer use. You use this when the task actually requires human-like vision and reasoning. When the interface is messy, updates frequently, or is highly unpredictable.
Do not deploy an AI vision agent just because it looks cool clicking around. Use it when the next logical step depends on what currently appears rendered on the screen.
API for clean systems, macro for fixed, rigid steps, browser use for messy, human interfaces. Beat? What's the ultimate payoff of this framework, actually, if an agent only saves you maybe 5 or 10 minutes a task?
It eliminates the constant draining mental friction of switching your focus between entirely different operational contexts.
Exactly. It is not about the minutes saved. It is about eliminating context switching.
Context switching completely destroys deep creative focus. It takes 20 minutes to regain your flow state after doing a trivial admin task.
An AI browser agent can open the banking portal, click through the dashboard, test the QA form, download the CSV file, and format the social media draft.
It moves the tedious visual friction forward.
And you stay entirely focused on solving the hard creative problems.
One single Codex task might only save a few physical minutes, but a scheduled library of these skills changes everything. You start with one annoying, repetitive task you hate doing every Friday.
Ideally one with no clean API.
Yes. You describe it clearly in plain English. You watch Codex run it a few times in headed mode. You tighten the text instructions. You save it as a repeatable skill.
Then you schedule it to run headless.
That becomes your very first autonomous AI agent automation pipeline. It fundamentally changes how a modern workday runs. You move from physically doing the tedious work to managing the intelligent systems that do the work for you.
Look at your daily routine tomorrow morning. How many clicks are you doing that rely purely on visual reasoning rather than actual human ingenuity? Which repetitive, messy UI task is going to be your first AI agent pipeline? Beat.
Thank you for joining us on this deep dive. We'll catch you next time.